I'm Dr. R, and this is my co-host, Dr. M. I'm wearing a lab coat, so you can tell that I know what I'm talking about. Anyway, today we're going to be talking about bases. More specifically, we're going to be talking about just how dangerous bases can be. Believe it or not, strong bases can actually be more dangerous than strong acids.
So, what is it that makes these acids and bases so dangerous, you ask? Well, to understand that, you have to understand a little more about just what these acids and bases actually are and how they react with one another.
Certain molecules, ionic and covalent, dissociate in such a way that they release a hydrogen ion without releasing a hydroxide ion. These substances are called acids. Since a hydrogen ion is really just a single proton in most cases, the chemist's definition of an acid is a proton donor.
Why do they donate protons? Well, take HCl and H2O for example. HCl is an acidic, polar molecule, and H2O is acting as a polar base. The Cl has a stronger electronegative charge than the hydrogen, so that side is negative. When in contact with water, the hydrogen feels a stronger pull from the oxygen because of hydrogen bonding, and bonds with that instead.
Wow, intense!
In contrast, we have the bases. For example, a typical strong base is sodium hydroxide, the principal component of lye. Sodium hydroxide dissociates to form a sodium ion and a hydroxide ion when dissolved in water. Water and sodium hydroxide can dissolve one another because they both are polar molecules. In addition, because the attraction between the OH part of the sodium hydroxide and the H2O is so strong, one of the H molecules will break away from the H2O, leaving behind an OH minus. As a result of this interaction with water, a base is defined as a proton acceptor. Most common bases produce hydroxide ions when they dissociate, and it is the hydroxide ion that accepts the proton. But why does that matter?
Because that's a major factor in what causes chemical burns. But what is a chemical burn, you ask?
A chemical burn is essentially damage to a protein, lipid, or carbohydrates in your body.
That sounds bad, but why does it happen?
Well, like we explained earlier, because of their natures as proton acceptors and proton donors, acids or bases will affect the protein molecules in your skin. A majority of the interactions that hold together proteins, both internally and to one another, and to carbohydrates, are hydrogen bonds, which can be very sensitive to the protonation state, and thus the pH of their constituents. Strong acids or bases throw this off, causing these interactions to break and proteins to unfold. This is why it's possible to cook an egg directly with acid. It essentially results in something similar to heating it with high temperature. Lipids can also be chemically modified by acids or bases, breaking up some of the interactions that hold cells together.
I see. But then, why are bases more bad than acids?
Remember, acids give ions, and bases take them. To put it simply, while your skin receiving more ions, more H plus ions, that is, can be disruptive, your skin losing H plus ions is far worse, and thus far more damaging. This is because the mechanisms of the body have evolved to use H plus ions. As a result, while having additional H plus ions added to the body can be disruptive, having the body's needed H plus ions taken away is far worse.
Of course! Because of that, strong bases, our proton acceptors, are more damaging than strong acids.
Wow, scary. Can my body do anything to protect against these acids and bases?
It sure can. Your body has buffers to keep your body's pH levels constant. These buffers work by binding loose hydrogen ions into the acid. Hydrogen ions are what make a solution acidic, so by removing these ions, the buffer removes the strength of the acid. By the same token, since hydroxide molecules are what make a solution basic, the removal of these molecules by the buffer make the solution less basic.
Wow, cool. But then how do bases and acids harm your body at all?
Because the stronger an acid or base is, the more protons transfer. At some point, the buffers are overloaded by the amount of protons going in and out of your skin, and that's when you get burned.
And, like we said, strong bases are better at this because they are proton acceptors and not donors.
That's all for now, folks. Stay safe, and I'll see you all next time. Dr. R out! That's all for now, folks. Stay safe, and I see you all. Co-host, Dr. M. I'm wearing a lab coat, so you can start again.